Hello everyone, I'm Renji, an engineer architect from the Alibaba Cloud database developer team. Today, I'm excited to introduce the evolution of AnalyticDB for MySQL Serverless and share our best practices with you. Let's get started with today's agenda. First, I'll explain the architectural design of AnalyticDB for MySQL and discuss the various business scenarios it serves. Next, I'll take you through the evolution journey of AnalyticDB for MySQL Serverless, highlighting key technical milestones along the way. Then, I'll showcase the advantages of AnalyticDB for MySQL Serverless by connecting it to specific business cases and exploring how we built its core capabilities. Finally, I'll share a real-world use case to illustrate these concepts in action. Now, let's dive in. AnalyticDB for MySQL is designed as an integrated online analytics engine that features decoupled compute and storage, supporting various open data lake formats. It offers seamless integration with multiple data source ingestion pipelines, including traditional OLTP databases, NoSQL solutions, and log storage. Additionally, it supports a variety of BI reporting and visualization tools, such as QuickBI and Tableau. We provide robust data development tools, allowing you to access and manage AnalyticDB for MySQL through Alibaba Cloud services, including Data Management (DMS). With DMS, you can conduct SQL development, orchestrate jobs, and manage your data lifecycle seamlessly. AnalyticDB for MySQL natively supports the MySQL protocol, maintaining compatibility with MySQL versions 5.6, 5.7, and 8.0. This means you can align data types for MySQL databases without issues. It also includes user-friendly features for online analytics, such as online DDL and real-time primary key deletion and update operations. Essentially, AnalyticDB for MySQL acts as a one-stop SQL analytics platform that effectively handles high concurrency real-time queries, ad hoc exploration, and offline ETL tasks. It provides both CPU and GPU computing capabilities, with solutions tailored for training and inference in AI analytics scenarios. With its hybrid architecture, AnalyticDB for MySQL combines a native database engine with an open-source Spark engine, allowing users to switch between engines as needed for their analytical tasks. On the storage side, the platform is equipped with high-performance in-house columnar storage, supporting automatic hot-cold data tiering and efficient cold data caching. It is compatible with popular lake formats, including Hudi Delta Lake, Iceberg, and Paymon. AnalyticDB for MySQL follows a compute storage separation architecture, enabling both online analytics and offline computing capabilities. Each layer, compute and storage, possesses independent elasticity. The internal storage engine facilitates real-time atomic updates and deletions, and the storage layer includes an SDK that supports stateless remote data reading. Now let's focus on today's main theme, serverless. I'll start by briefly outlining the serverless development journey of AnalyticDB for MySQL. Initially, we introduced resource groups within a traditional MPP architecture to enable compute storage separation and business isolation. Resource groups operate similarly to Snowflake's virtual warehouses, allowing independent business units to achieve compute elasticity. Building on these resource groups, we developed a massively parallel processing MPP execution mode for interactive queries and a bulk synchronous parallel BSP execution model for batch processing. These execution modes are tailored to meet specific business needs. For the MPP execution mode, we implemented multi-cluster scaling, while our BSP execution mode features on-demand scaling. In our latest kernel version, we unified these execution modes and elasticity strategies into a consistent framework, introducing resource group isolation, which enhances node isolation within resource groups. Users can now create multiple resource groups on a single storage foundation, each tied to different SQL accounts, effectively isolating compute workloads for various businesses. Resource group nodes are stateless, allowing for quick, manual scaling and flexible, time-based elasticity policies that accommodate both interactive and batch processing. Let's explore the specifics of MPP and BSP execution modes. MPP mode schedules all execution tasks simultaneously, maximizing resource utilization and memory efficiency, which is ideal for short queries that require rapid response times. However, in complex ETL scenarios, MPP mode can significantly strain cluster performance, potentially leading to OOM exceptions. Conversely, the BSP execution mode decouples SQL execution into stages, executing tasks serially while temporarily storing shuffle data on disk. This significantly reduces peak memory usage during execution. For the batch query groups operating under BSP mode, we utilize on-demand elasticity by maintaining a resource pool that allocates one small specification physical node per task. This ensures resource isolation during batch queries, resulting in improved stability and completely on-demand elasticity. In cases involving interactive query groups under MPP mode, we observed fluctuations in traffic patterns that resulted in high concurrency demands. To address this, we introduced a multi-cluster elasticity model inspired by Snowflake's concurrency scaling. When queries queue up, we can scale compute nodes by replicas, enhancing throughput for small queries. In our tests, replica scaling provided substantial improvements in small query concurrency compared to simple horizontal scaling, as traditional horizontal scaling often incurs higher distributed overhead. This year, we have introduced a unified elasticity model with auto-scaling resource groups. This strategy simplifies the resource allocation process compared to the multi-cluster elasticity model. In the past, users often struggled to determine the right cluster sizes, which can lead to resource wastage or the inability to handle demanding queries. While our new auto-scaling resource groups can flexibly scale within a cluster using minimum adjustment steps of 16 ACU while adhering to predefined min-max constraints. This approach significantly reduces the complexity of resource estimation for users, focusing instead on their budget. If users set the minimum resource to 0, they incur no compute costs during idle periods. Within the auto-scaling resource groups, we employ a unified bubble execution mode along with Smart Query Acceleration (SQA) technology to handle mixed interactive and batch query scenarios efficiently. When queries are submitted, the optimizer generates execution plans, estimating resource requirements. A binary classifier then determines whether each query has a low resource footprint, allowing these queries to be scheduled on single nodes. This single node scheduler is equipped with load balancing capabilities, ensuring optimal distribution of workloads. Resource-intensive queries undergo comprehensive resource estimation to accurately gauge their consumption before execution. The bubble execution mode segments queries into manageable subtasks for serial processing, based on the user's specified resource limits. With our intelligent resource management system, different query requests are queued, and global resource schedulers manage the allocation process. In scenarios where resources are insufficient, our dynamic scaling strategy ensures that nodes are appropriately adjusted. Through kernel-level resource quota isolation, we establish stable execution environments for various query complexities by binding CPU cores and applying memory and I/O constraints. Our elastic, temporary node scaling has an impressive response time of just 5 seconds. As we continue to enhance the storage capabilities of AnalyticDB for MySQL serverless, we store all data on object storage and manage real-time traffic efficiently. Data is aggregated and compressed before being uploaded to object storage, complemented by region-specific compaction services for incremental data merging. Looking ahead, we aim to enhance the serverless experience by providing full-stack serverless solutions that offer ready-to-use instances. When purchasing these instances, users will benefit from swift, on-demand access without the need for traditional resource alignment or software deployment. Additionally, we are introducing ERDMA, a multi-tenant memory pooling technology that further separates CPU and memory resources. This addresses the challenges posed by uneven memory utilization and the fixed ratios of physical nodes. To summarize, here are 5 key capabilities brought by the autoscaling resource groups in AnalyticDB for MySQL Serverless. These are also the reasons to go serverless. First, Query Resource Estimation Framework. This framework distinguishes between large and small queries, providing accurate resource predictions that enable more effective scaling. Second, Small Query Acceleration. Our SQA framework supports efficient execution of small queries on single nodes, enabling linear scalability in terms of concurrency. Third, Unified Bubble Execution. This approach smooths performance discrepancies between MPP and BSP execution modes, optimizing query performance even with limited resources. Fourth, Intelligent Elasticity. By combining physical resource loads and request queues, our autoscaling strategy makes informed decisions about resource allocation. And last, kernel-level query isolation. This feature ensures that queries are processed in isolated environments, enhancing overall system stability and performance. In conclusion, autoscaling resource groups in AnalyticDB for MySQL Serverless brings significant advantages. Here are 4 points I would like to address. Number 1. Improved resource utilization. By eliminating the need for multiple resource groups, we reduce waste and optimize allocations. Number 2. Enhanced query performance. The bubble execution mode drives superior performance, especially for small queries. Number 3. Greater cluster stability. Our frameworks are adept at handling both unexpected spikes in traffic and scheduled ETL processes. Number 4. Cross-AZ disaster recovery. We now support swift disaster recovery across availability zones, ensuring minimal downtime. Finally, let's discuss a practical business use case. We have designed a solution that combines serverless autoscaling resource groups with materialized view functionality. The materialized views in AnalyticDB for MySQL support various base and result tables, allowing for minute-level incremental refresh with near real-time data accuracy. These views significantly accelerate real-time computations. Previously, refreshing materialized views was resource-intensive, but now, with our autoscaling resource groups, the refresh process is both stable and efficient. Resources can be elastically scaled during the refresh, only to be released once complete, leading to a productized serverless materialized view capability. This approach offers several benefits. First, cost efficiency. Users only pay for the resources utilized during refresh operations. Besides, performance. Elastic scaling guarantees optimal performance during these refresh tasks. In addition, stability. Isolated resource allocations prevent any interference. What's more, automation. Resource management is handled automatically, requiring no manual input. In summary, AnalyticDB for MySQL Serverless is a remarkable leap forward in cloud-native analytics. First, unified execution. It seamlessly manages both interactive and batch workloads. Second, intelligent scaling. With a 5-second response time and smart resource estimation, it adapts to needs on the fly. Third, cost optimization. Enjoy true pay-per-use with no minimum scaling costs. And last, enterprise-ready. Benefit from cross-AZ disaster recovery and kernel-level isolation for optimal performance. We are enthusiastic about the future of full-stack serverless solutions and look forward to continuing our journey of innovation alongside our customers. Thank you all for your time today. That concludes my presentation.